Hello friends, my name is Chinmay Deshpande and today we are going to see a concept of ADC used in Arduino 328P with its functions. Objective of this video is, after study this video lesson, you will able to understand the concept of ADC in Arduino 328P, meaning of functions which are associated with ADC. There is a difference between an on-off sensor which detects the presence of an object and an analog sensor whose value is going to continuously change. So in order to read this type of a sensor, we need a different type of a pin. This is the structure of Arduino UNO. Now it consists of 6 analog pins which starts from A0 to A5. These special pins not only tell whether there is a voltage applied to them but also its value. Microcontrollers are called as the devices which deals with the digital information only. They only understand 0 and 1. So an ADC, that is analog to digital converter, is a very useful feature that converts analog voltage on a pin to digital number. By converting from analog world to digital world, we can begin to use electronics to interface to the analog world around us. Now let's see the first function, that is analog read function. It is analog input function. Its meaning is this function is used to read the analog input voltages between 0 to 5 volt, and it will convert this value into a decimal value that will range from 0 to 1023. Now the question is, why it is from 0 to 1023? The reason of the value 1023 is because the ADC in Arduino works on 10-bit binary signals, which means that maximum number will be 2 raised to 10, that is 1024. So it starts from 0, that's why here we have written from 0 to 1023. For example, suppose if the analog value shown is 0, then its digital value will be a 0 digital. If the analog value shown is a 5 volt, then the digital value, its corresponding value will be a 1023 decimal. So for a 2.5 volt, we can write 1023 divided by 2, that is equal to 512 decimal. Syntax for this is int VAL equal to analog read pin. This pin indicates the number of pin whose mode we want to access. Int VAL equal to analog read A0. Analog input voltage at A0 pin is read by this function, that is analog read function. It will get converted to the value from 0 to 1023 and it will be stored in the variable VAL having integer data type. Next function is analogReference function. Again, it is an analog input function. Description is this function is used to select reference voltage type. So syntax for this is analog reference into bracket type. For example, suppose we write analog reference default, then its meaning is going to select a default voltage of a Arduino board, that is from 0 to 5 volt, or it may be from 0 to 3.3 volt also, depending upon type of Arduino board used. Now next function is analogWrite function. Now as it is a write function, so with respect to the Arduino board, it is output function. Its description is this function is used to generate a PWM waveform at digital pins D3, D5, D6, D11 and D12. Remember that these pins are able to produce PWM waveform. Now this is what is a diagram of Arduino UNO board. The shaded region indicates that these are the digital pins, and if you observe carefully the symbol which is shown here, this is what is a symbol, then tilde symbol. Pin number with tilde symbol indicates that it is used for PWM purpose. For example, tilde 3, tilde 5 indicates that these pins can be used for PWM purpose. Next is analogWrite function. Syntax for analogWrite function is pin comma duty cycle value, where pin indicates number of pin whose mode we want to set, and duty cycle value, that is it is a value in between 0 to 255. 0 indicates that always off, 255 indicates that always on. So suppose if I write analogWrite 5 comma 255, then its meaning is generate PWM waveform of 100% duty cycle at digital pin 5 of Arduino. So that 255 indicates that 100% duty cycle generation. Now remember, in case of analogWrite syntax, duty cycle scale is from 0, that is always off, to 255, that is always on. So for 100% duty cycle we have taken corresponding value 255. Now suppose I want to have a 50% duty cycle, then its corresponding value will be 255 divided by 2, that is equal to 128. So likewise you can give an example for 25% duty cycle, 10% duty cycle. So the example for this is analogWrite 5 comma 128. It generates PWM waveform of 50% duty cycle at digital pin 5 of Arduino. Thank you for watching this video. Please subscribe my channel, like, share and comment this video. Thank you.